Thank you. My point is here to Sahu, like whether we go for wet or dry, the load on the foundation, how it is getting changed. And so finally, ultimately, how much more pressure is getting generated in terms of when we are saying we are reducing the water, but adding the weight, what is happening to the strength of the soil or what you say bearing capacity, how much it can take it. So in that respect, the foundation for the dry stacking versus slurry, which can go up. Yes.
Because in a dry stacking now your load that is applied on the foundation is higher compared to wood stacking. But in the meantime, you will achieve higher storage. And second thing, now we are discussing that in wet tailings that water content is about 50% or 60%. Now in dry, it is 15%. Okay. But that 15%, whether within that 15% the tailings is fully saturated condition or not, that is one important factor. Because in a dry stacking, you have to let these tailings in a layer wise. Generally, we are compacting in a 95% or 90% of OMC. Okay. So that due to that compaction, so now we have to see it is whether it is sticky material or non-sticky type material. If it is sticky clay type behavior, then its compaction may not be proper. Okay. So that may gradually develop the excess porous pressure. But if it is a drain type, sandy type material, then there is a possibility whatever the 15% water that may be drained out and the proper drainage system can be arranged. Then this future preliminary thing, so that we have to decide what is the type of tailings. Based on that, if it is a draining type, may go for dry stacking, that will, and if it is sticky type, then we have to consider what are the other parameters to see. So that is my view.
Thank you. So, Subhash, can you think about the difference in challenges?
Challenges due to on the constructor point of view, sir.
Yes.
Actually, I have not directly worked in a dry stacking, but one of my colleagues has worked on this dry stacking. So the problem he faced that whenever there is a, in Indian context, that filtration plant, that efficiency was not good. So the outcome from the filtration plant, the water content is more than 25%. But the claim was that 15% will achieve, but the water content is going higher. So the entire design was based on the input. And when they put the material in a dry stacking area, and during monsoon, the water content again increasing, there is a difficulty for spreading the material and managing the material in a pond, in a area. So that problem from the company's perspective, and when we suppose the person has visited the site, he found that in one staking they have gone up to 20 meter height, another staking is 15 meter height. So there is an unbalanced load all over the places. So how to deal that? Because that is not in his designer hand, that is the operational people who can decide that how to manage this dry staking. Another thing, that should be a surface water drainage management, which is missing in most of the dry staking. They are thinking, there is a myth that we have dry staking, so there is no water, so we don't require any water treatment or something like that. So that myth needs to be taken out of this context. And we should think that in Indian context, monsoon is a period, 3 months period, where we need to concentrate, and before monsoon the planning should be there. Otherwise you cannot dry stack the material properly. And similar thing, the pumping arrangement. In dry stacking, I have not seen any pumping, standby pumping in the area where the monsoon water can be catered. That needs to be taken care in the operation team. In dry stacking also, there should be a gradient towards one corner, or some arrangement should be there. So the water will accumulate on one corner. From that corner, we can continuously pump the water to the plant. That is the problem on construction aspect which I learned from the colleague. So that I am explaining.
Thank you.
Just I want to relate it to foundations, just from experience that Dr. Misra and myself were involved. So it was a dry stacking over with tailings. So when we were putting this dry stacking, so generally there is common sense that that client told now there is no possibility of liquefaction. Okay. Then when we checked, when we were adding this dry stacking, that weight is increasing. Then at a certain stage, what it comes, that static liquefaction happens. because already in wet tailing already moisture is there. Okay, so that is already inside the below the ground surface. So finally, when we are raising now the weight that we are adding, that is much more than this current state. Okay, so in that case, then you have to go for some ground improvement techniques. Clear? Then we can improve in that case that first you have to improve the foundation or the foundation tailings. Then we can go for dry stacking. So that initial cost will be higher. Okay, but for long term, it may be better option. We cannot say, but possibility.
Okay, Dr. Akila.
Yeah, I'd like to agree with Sahu sir, because recently we visited one site. Like since currently the filter tailings have come into trend, and initially most of our facilities were following the slurry kind of deposition. Now everybody wants to come into filtration. So they really want to jump into it altogether. So existing slurry tailings are existing there, and the stacking will happen on top of that. So that it's not going to be a fast process. Like sir mentioned, you have to go for some big drains or some additional arrangements and allow the water to drain out and to make the foundation for your stacking more strong. So it is not going to be a fast process. That is the first thing. Second thing is, see, slurry you will just deposit through spigoting. It's very easy. Some corners you will just spigot it. But in stacking, you really need to compact it and make sure that whatever you are depositing is in a good shape, so that it doesn't fail by itself. So that process is also needs to be considered. That if you are having a tailing and you are going for the dry stacking, then you need to make sure that stack itself is a stable unit, so that it doesn't undergo any unnecessary failure later on. So it's not an easy process to just jump from a slurry to a dry stack tailings just because it's going to be a trend. So lots of analysis and pre-treatments would be involved.
Okay, thank you. Because this dry stacking, why I want to emphasize, many of the companies are now going for most of the red mud, narco and other things. They want to jump to the dry stacking. So that's why this is a matter of concern, though. Like the system may be different, but I will say that we should also take out some of the idea that dry stacking means no concern. So that was my worry, because people think that because once we are going for dry stacking, we should not have any worry.
Yeah, like I can make a statement that whatever things or principle we are following this slurry, we have to exactly follow the same principle. I don't think anything will change on that. Like monitoring system, management, water management system, tailings management systems, all should be same. And in one of the project, again, it was also related to red mud. One alternative was that can we use the existing pond for the dry stack, which in the, like, we didn't do much, I didn't do like much investigation, but I gave them some examples like what people have done in the past, so I didn't encourage that.
Okay, thank you. So now suppose say, now we have got some coming to design consideration and on-drain shear strength. So there we are talking about one limited method, and again we are talking about advanced method like finite method or finite difference method. So from on-drain shear strength to critical state method, limit equilibrium and advanced computer method, how they are compatible with each other?
Again, the like on-drain shear strength is a parameter. So whether we use limit equilibrium method or again we use the numerical method, the parameter is not changing, but only the problem is in the numerical model is a stress deformation model. So we need the modulus value, because you have stress and then displacement. So if you follow the simple linear model, you have a modulus. So that modulus, you have to get that. And again, we get that in several different ways also, that modulus. And the issue of undrained shear strength, again, we have a model of undrained shear strength that also we can use in our constitutive model when we do for the numerical analysis. So all these things we can do, but the problem is what is the value and how to determine that value. So we were discussing yesterday, like the initially lot of lab testing has been done on that. So we have lab test, if it is done properly and we have good, the problem with the tailings is getting a good on disturbed samples where we can do sophisticated tests. Like we are just doing a triaxial test, but again, we are doing much more sophisticated test than the triaxial test also. But again, the problem is finding the good undisturbed sample. So most of the test we are doing right now is on the remote samples. But with the advance of cone penetration test, CPT test and further good interpretation, we are getting better result on that undrained shear strength also. So that we are using in many, I am using that CPT strength in many projects, and we are okay with that method. Yeah.
Thank you. Dr. Mishra, you want to add something?
Understood your question correctly. You wanted to ask how the advanced models, the methods compare, and how the brain shear strength comes into picture there. So I think really the way I look at it is limit equilibrium. We have all read about limit equilibrium methods in our books, textbooks. So it simplifies the geometry, really easy to do and very easy to get. The computations are not difficult. So if you're simply after very simplified assumptions, you just want to find factor of safety, simple, go for limit equilibrium. However, if you want to, let's say, you put some instruments on your dam, and you would like to set some taps or what we call as trigger action response plan for your inclinometers or piezometers and whatnot. I think that's where you find limit equilibrium finding its limitation. You need to go for finite element modeling or some sort of like Plaxis or something, and they didn't want to take any name of any commercial software, but that's what we use. So something like that, we can actually provide you for different trigger levels, what would be the required phreatic level for your piezos and your deformation inclinos and whatnot, and then you can use that to monitor your facility through. Also, in those circumstances, you advanced models such as finite element and finite difference model are really helpful. Now, if you look at what's available in the market in terms of software, perhaps you see that when we talk about limit equilibrium method, mostly we use GeoStudio, which falls under Bentley. And if you look at finite element and finite difference, Plaxis is also Bentley. We have used unsaturated software which is called SVSlope. Now that also falls under Bentley umbrella. So it's really sort of a monopoly. I didn't want to call it out, but it is more of a monopoly. You have flat, rock sand, and whatnot you can use, but I agree there's a lot of consultants in the room. Bentley is what you would end up using. Now when it comes to getting the undrained shear strength parameter from the lab or in situ, I agree that the challenge is getting the demolded sample, getting the undisturbed sample. So on most of the time and most of the consultants would agree that CPT is the new standard, and it is the industry norm to get SU by sigma ratio, which we use as a undrained shear strength versus the overburden stress ratio. That's what we use for our models and input. in the laboratory, if you're doing fractional tests are really good, but sometimes they take so much of a bit more time than standard. So I think another trend is to use, if you are competent enough, simple cyclic or simple direct shell test sort of that, and that provides sort of a negotiation between your direct shell and the track shells here. So the numbers, there has been some studies reported, and they said really, in between. The time taken is not that much as track shell, but it's a bit more time intensive compared to direct shell, but still you get some good results. So if I have the option, if it was up to me, I would always rely or use my numbers from real field data, do a CPT test at several locations, find out your issue, use that in membrane analysis. I've really challenged the the membrane numbers, or the shear strain numbers that we get in the lab. There is one study which shows that from the time you take the sample in the field to the time it is placed in your track cell rig or any of those instrumentation rig, you induce a void ratio change of 0.15, which is significantly less. Like, it's not too much, but what you do when you find the CRR, or the cyclic stress resistance, or CSR, or whatever that's called, it becomes 5 to 6 times more. So if you use that, that's not the case in the field. So it becomes, even if for that small amount of densification that the sample has undergone from the time of extraction to the time of testing, that results in conservative numbers being generated from the lab testing. So in situ testing is something that I always rely on. That's.
Thank you.
One is the limit equilibrium, and other is we are saying finite element method. So limit equilibrium basically only gives the factor of safety, and for which you only need our shear strength parameters. So for short-term condition, we are determining only this on-drain shear strength, that is the factor of safety. But that is not sufficient. That gives maybe slope is stable. But overall, if you say with the time, there is a change of state of stress and the strain. Okay. So when there is a change in state of stress and strain, there is deformation is continuing. That further determination we have to go for finite element method. Then in that case, there are two conditions generally what we are discussing, on-drained and drained condition. So during the construction time, generally it is mostly we have to use for on-drained condition. So when you get this deformation part or displacement, then in addition to C part, we need also modulus of elasticity and the position ratio. That also we can determine from the lab test. Okay, but this on-drained shear strength, that also we can determine from the CPT. There is one empirical correlation. If the CP2 results are available at hole penetration resistance, then also we can determine what is the on-drained shear strength. That we can correlate with the lab test. One is the undisturbed sample in the field, another is the distortion sample that we are doing in the lab. Then we can find out what is the basic difference in these two, what are the values. Then in finite element, when we determine this deformation, so during the construction time or up to at the end of construction we can find out. Then after that it starts, your construction is stopped. Okay, now gradually at the long term, so whatever is the final say deformation, for that we may go for this drain condition or drain modulus of elasticity, position ratio. Generally in most of the cases the position ratio there is very less variation. So but if it depends upon what is the type of or fineness of the particles, that is one important parameter. So from that again we have to go for, that is most important in these particularly tailing dams, rather compared to factor of safety. That is, we are giving one preliminary idea that okay, now it is stability point of view safe. But in long term, when we consider that deformation part, in that case that stress strain or stress deformation analysis is the most important part to me, it means. Okay. So for that, then those modulus of elasticity only we can get from the stress strain behavior. But in the meantime, it is difficult how we assure that value is correct or wrong, because we are using from the lab test data. So how that specimen is prepared and which did the analysis, how the results are interpreted. Just yesterday, Dr. Das told that CP2 results, okay, it is fully plunging. Out of that, how we are extracting the final shape of that pore pressure distribution. So in the similar way, these also affect, but we have to consider this is stress deformation analysis, which is a must. Okay, so that must be done for any bonds, for the long-term analysis or short-term analysis.
Okay, thank you. So from concerned person, which you feel quickly you can answer?
Sir, actually we are dealing with only the limited fluid as of now. But I want to know from the experts that can we do a coupled analysis with a limited fluid and a numerical model?
I think I showed you that. So the seepage analysis we do using numerical model, and that generates the pore pressure like the CW. And we can couple CW with slope W.
What about sigma W, sir? Sigma W is also...
Yeah, sigma W also I have used sigma W, because that sigma W also we use when we load it. Because CW will not do any loading. So when we generate that pore pressure, that's a coupled model, CW and sigma W.
So first we will do the CW model, then that model will go to the sigma W. Then
Both CW and sigma W are coupled.
And then the file will come to the...
Then that they will generate the pore pressure, and that file will be shared with the software.
So this way we can manage that one.
This way we can manage that.
Okay, then we will try that one. We have not tried that one completely. So as industry we have to go with the only the whatever the easy way to do it. So that we are following now.
Yeah, there are now like when I was doing, like I started with the black model, and then like I shifted to the sigma W, CW I have used a lot. But now like Dr. Misro, he was mentioned classes, I have used that also. And there are other models are also available. Bentley, they have good models also. I have reviewed them. So like the most important thing I can tell you, when you do simple limit equilibrium model versus numerical model, the difference is you need to know more about the site doing the numerical model. The site characterization is a must in numerical model, because you have to get a lot of parameters.
So here one more question. Suppose the tailing dams are very big and we did 3 or 4 numbers of CPTU test, and all the CPTU has different results. Then how we can take that parameter in the design?
No, again,
Because it depends on the deposition strategy. Some the deposition strategy is different. A plant has operated for 30 years and different time the operational people changes the deposition strategy. So the deposition at one location CPTU is showing different. Same after 500 meter the CPTU deposition showing a different.
yeah. So like that's what I was telling you. In the 2D model, we always use a critical section. So that critical section, the data will drive what is my critical section. And like I mentioned, like we see that the section is highest section, or it is slope is steepest. Also we look into if there is a higher pore pressure in that section or not. Because exactly that condition you have to see. Like you are getting 3-4 things. The good ones are good. I don't have to worry about that. I will be focusing on the weak one. Because if our the concept is weak zone is, I call it a weak zone model. If my weak zone is stable, I don't have to care about all
the
that.
weak zone is spread over a large area, sir.
Mhm.
It is like one stretch it is weak zone is there,
Yeah.
another stretch that zone is good, then another weak zone is there.
Yeah.
But that height of the dam at that zone is not so much.
Yes, height of that is not so much, but in your maximum height also, you don't have every point, no? So once you find that there is a weak zone exists, then we have to assume that weak zone exists.
So that it comes from a judgment how to.
Exactly, yeah. Because weak zone is there, we don't know where it is. And we don't have evidence that in the highest section there is no leach zone. We don't know that because we have only one CPT data.
And sir, what is the effect of the aging of the material deposition? Suppose the pond was operated 10 years back, now there is a lean period, there is no deposition in the pond. Now they started again reopen the pond.
Yeah, no, I have looked into that, and in some of the tailings dams which was like stopped, it's not closed, but they are stopped for 20 years. And when I look into the pore pressure data, they are steady, there is no change. So that means what was 20 years back, it is still same thing there. That pore pressure is staying there. So we have to mainly look into the pore pressure data. Because if we see a change in the pore pressure, like if it should decline. If it is declining means that our concept is working. Because we see that when it stops, it will go to a steady state level. And steady state level is possible if the pore pressure declines.
Another thing, sir, operational point of view, now the industry is doing, suppose they are not increasing the height, they are not increasing the loading, but they are evacuating the material from the pond and they are refilling with the new slurry. So what will be the effect on this process of operation on the pore pressures?
Again, that I think you told me yesterday.
Yes.
Yeah, that's a complaint. We have not done that.
But
So
in India, that is a common practice now, evacuating the
no. India is doing so many things. Especially the fly ash.
Yes.
And then this technique like how you are using the post-grain like the boulders or things to stabilize it so that we can put a new layer on top of that.
How it will this affect our pore pressure in the system?
Again, the problem is when the pore pressure is, say you are the load layer, there is a pore pressure there and that is taking the maximum load because all the loads are coming there. But if the lower layer is a good drain layer, then you will not find any pore pressure there, it will drain down. But then comes the middle layer. It all depends on which layer has that pore pressure. And why the pore pressure is not changing. Like if you do not, if you put load, it is rising. If you don't put any load, it is not changing. That means it is not draining. There is no path to go anywhere. It is staying there. So if you load it, definitely it will increase. But if you have some piezometers exactly where that water is, then you can easily monitor that. But again, depends on like what you are doing is good. But if you do not have piezo data and other things, you are like again just doing it and just waiting something will happen, then you will investigate.
Rakla, you are...
I just have one question for sir. Anybody who can answer. My point is, like, why don't we go for critical state based designs? It is conservative, but that will ensure that the properties are not varying much at the end of the day.
Like I showed you the critical state there. We are doing that. Yes. Right now, most of the models we are working on is the first of the critical state.
So if we do a CPTU and then we
But the issue of the critical state is, you know, the critical state is dependent on the exactly that leach zone. So first you have to identify the leach zone and then define the leach zone. But in general, you cannot make a critical state. It has to vary with the like you have fine soils, you have intermediate soils, you have coarse soils. So again, the coarse man cannot do that, but like again, I was mentioning you have like dilatant behavior and contractive. They are the contractive behavior you identify, and then that is will be your critical state will be the answer.
So it would be like a blanket solution.
Critical state. Yeah.
Okay.
Right now, people are working on that.
Thank you. So now we have done lots of technical things. I will now come to something like for the benefit of the delegates from industry, because this was enough discussion on the people from technical education, students and researchers. So they might have got a good idea about it. Now suppose say my question is, so now suppose a GISTM, if comes to India, how it is difficult for a company to implement it? Because there the hierarchy system, I mean there the requirement is the personnel. So many personnel has to be there from the owner side, and in owner also there has to be different chart who should be the engineer, certifying authority and so on. So what do you think, I mean now I'll ask with Dr. Ponda, how they manage in other countries for this GISTM?
No, like again,
GISTM came in 2020. So, but we were previously also we were there. Like it's not that it is completely new for us. We had a ITR before. We had that, and we had a UR. Again, UR is a very common thing there. Any project we do should have a UR because that person
You are engineering of record.
engineer of record, UR. So because that person will stamp it, the engineering firm. So he is the responsible person. If anything happens, then he is also the culprit. So that concept was there from the very beginning. But they have now put some more things. And also, we will see that the GISTM is not only the technical part, also the social science part. So when we started with our client, like how we will be compliant, then we need for a social scientist. I mentioned we need for a social scientist because we need her in that for the help of that person also. So all these fulfilling all these things is there, but most of the client, they are our clients. They are looking for that and they are ready to do that.
Okay, so now just what I can say before going further is, Dr. Mishra, you want to add something regarding the GISTM implementation?
The way it happened in Australia, I think when 2020, failure of 2019 happened. I would not name the companies, but many companies went for sort of a GISTM audit or GISTM conformance for individual sites that they had. Many occasions, I mean, a lot of the sites are not designed with closure in mind. This is how I think if you're starting a new site, you design with closure in mind, how the final landform should look like. But many sites have not been designed like that. So first thing we have to acknowledge that all of the sites, even though we want to, we won't be able to fit them to the GISTM. That's an acknowledgement we have to make. The second thing is that how do you manage about, how do you go about it? Well, most of the dams that we have in New South Wales, Australia has state-based legislation. Dam safety New South Wales says something as allowed or as low as reasonably practical. So you showcase that all the risks that you have for your dam, you have put enough amount of controls in place and you are managing the risk to the best possible abilities. I think that would show that your intent as a business is in line in terms of reducing the risk. And when we talk about risk, in most of the risk assessment that we done, it's the people risk that's the biggest risk. So I think that's where we need to be more sensitive about. It's very unfortunate when I talk about Indian scenario. Dr. Das should remember we went to a site together for an inspection to the TSF, the slopes were 1 and 2, and people were literally climbing on that slope. The mine manager was there. We asked, what is this, why don't you have a barricading there? And the manager like, yeah, sir, people come and they fall in the pond which is below, we pay them 5 lakh rupees, that's how it, I was very surprised. Most of my technical knowledge happened in Australia, we are very safety conscious. That putting 5 lakh rupees to someone's life in India, it's a very unfortunate thing, but I think the value of how much a human life is, it depends on which country we're operating. It should not be like that, but it depends really on which country we're operating. You kill one person in Australia, the company will go bankrupt. I don't know if I can say the same thing about an Indian scenario, but building that sensitivity just because we have 1.2 million or whatever number of people, one person's life does not matter. That mindset we have to come out of. Like everyone's life matter, you design with end or closer in mind, and then you make sure that these are humans, these are your environment that you're dealing with. I mean, what is our legacy? Like if we have a future generation and we leave a site or a mess, or we design a facility which is not properly designed and we leave for our next generation to come, how would it look like? Think about, if you ever lived in a shared house before, think about your housemate cooked, did not clean and left in the kitchen, how would you feel when you come back to that? So that's how our future generation would feel like if we do not manage it properly. So I think the major challenge in terms of Indian scenario would be developing that sensitivity. And that sensitivity should not come from a threat. The threat being, if the dam fails, I get penalized or I get sued. It should come from general, general sort of empathy that being an engineer, your loyalty should be just to your company and whatever. That's why there's the money and whatnot, but towards the public welfare. If you design with that in your mind, then I think that will be a big achievement. So that's what I would say. For us, most of the people talking when one person goes or a catastrophic failure happens, for us they become a number. But think about the family that they belong to, like what the family would go through. So when you think about that, take for example Madina. So a lot of people lost their lives, and we spoke about companies getting bankrupt and whatnot, all of those things valid and fair points. But what happened to those 270 people and their families? So being a little sensitive, thinking about these aspects would go a long way. So those are my 2 cents or $2 because I spoke too much.
Okay, thank you. So now what I'll do, because that GISTM says zero fatality. So now what I'll take question from the delegates here. So let me start with anybody from Balco can tell the best problem they are facing in their operation, or somebody from anybody from Balco. Yes, tell what is the most difficult part you are facing as a tailing engineer.
सर हम लोग के जो हैशटैग्स है वो हम लोग के रेड मड फॉन्ट पे कंस्ट्रक्ट हुआ हैशटैग, तो जो हम लोगों के सीपेजेस जो होते हैं वो हैशटैग का वो रेड मड से क्रॉस होकर आता है, पास होकर आता है, तो जो सीपेजेस है उसमें हम लोग को कास्टिक मिलता है।
Okay.
तो एज ए ऑपरेशन हम लोगों को पानी को कलेक्ट करना और उसको कैसे ट्रीट करना है, उसको पानी को ट्रीटमेंट क्या करना है उस पानी का, जो वाइटिश लेयर पूरी स्लोप ड्रेन पे हमारे क्रिएट हो रही है अभी।
Okay, any of the expert, I mean the panelist, any of the panelists, Dr. Panda, you want to add something? Because it's a typical situation, it happens in India, as you said.
No, like you mentioned that the water is like the surface water is coming.
No, sir,
No.
seepage water.
Seepage
water is passes through red mud dye and coming to the ground level.
So which seepage water that is? Where the seepage water is coming?
From inside the dike, sir.
Sir, actually on the red mud they have built the ash dike. So whatever the deposition coming to the ash dike, that means ash is free draining material, so it is passes through the free draining material, then it goes to the red mud area, and from the red mud that there is a rock toll surrounding the red mud area, and the caustic is coming to the toll drains through the filters. So that is the problem they are facing. It is first nuclear reactor where there is a construction of different material on the different.
So actually, you can add or I can say something?
Yeah, you can.
Okay, because this is not your problem, that problem also I have seen in another case where BP tailing through that dam which is built out of the GGVS, I mean blast furnace slag, which is very coarse. The embankment is there, and then through that BP tailing leachate are coming out. So that pH is very high, so that very caustic what you said. What they have now done, they have stored that water and treating that water to make it potable, I mean reducing the pH. Because the problem was there, now what you cannot leave it outside. Because this case also happens in a chromite mine. In chromite mine, when they are processing, if the rainwater comes out also, that they can leave it outside. Because that hexavalent chromium, what is there very, carcinogenic. So that's why what they do, they collect that water also, then they treat it and then allow. So in that case, because the way what you have done, you have no choice. You cannot leave that water to outside, because if it goes to the any agricultural field, like what has happened in different area around the redbird pond and so on, then this is environmental issue. So for that reason, what they do, they store around, because in fact, people yesterday I was talking about this water management, water storage imbalance. So there also, if some leachate is coming out, that also you store it, and then you treat it.
Now we have constructed the garnet drains.
Yes, garnet, but then that water you cannot allow also to go outside.
We are taking that water inside of plant.
That is fine. So that water you have to collect, bring it back or treat it and leave it, because that company is treating it now. So I don't want to name the company, they are now treating. Because last time I visited, I found fruitful seepage. Because you see the embankment is out of slags. So very much porous. So through that this water is seeping like anything, the water is coming. So that water, instead of changing now anything, so they are now storing it. And storing water, they are treating it. After the treatment, they are leaving it. So that process you can do it. Okay. So similarly, if I can ask from, yes please. Anybody want to add anything?
I think Professor Das, I also
Yes,
want
please.
to say that it's environmental concern is one, but I would also encourage that that caustic water. I have dealt with that situation before. We recently had a safety issue with someone's, like the caustic water went into someone's eye because they were not wearing safety goggles, and basically you end up losing your eye. Your ISPS should be 7, it goes to 10, and so there's a safety issue. But what I was alluding to, we can also look at some innovative solutions, because we know that in geotechnical engineering we talk about alkali activities. But if you want to use that, that may be a potential use in alkali activated materials.
Dr. Mishra, that we tried. That water, caustic water we had taken in one case to add for the alkali activation, but it didn't work because the equivalent sodium hydroxide is very less. And another thing about the causticity, this has happened to one of my students. When he was using this one, his eyes were just like coming out. First time we could not know what has happened, because that caustic things is so laboratory, because we don't follow also the laboratory protocols like it happened in the advanced countries. So C had a sensitivity, that depends upon the sensitivity, or just, it was furious. This was that eyes that was just like coming out, she was looking different. Immediately we sent it to the health center, and because the caustic, what Dr. Mishra said, is not that easy. We have dealt it with also, and we have faced these difficulties. Okay, so now I'll take anything from, suppose say Hindalco. Hindalco, 3-4 people are there, so they can take one problem. Yes.
Like we are from unit, so we have a major issue with respect to the operation of the pond. Like we have a redwood pond, where initially 5-6 years it has been a wet pond. But after that there was a dry stacking, because filtration unit has come, and then we had a dry stacking over the wet ponding. But there is a issue is that the underground of the pond there is a water stream. So during the monsoon, what happens, because of the high pore pressure, the water starts coming out from the bottom of the pond, and the pressure is such high, if there is no regular deposit over it, then it breaks the liner which has been laid at the bottom, and the water rises to almost 15-16 feet high. So what to do for that?
Okay. So Dr. Panda, I'll let you start with Dr. Mishra. Any clue you have got?
If I understood correctly, just correct me if I'm wrong, I'm rephrasing the sentence. So you had a the old wet storage facility, and then you are transitioning to dry storage facility. But because of the geology condition, you have phreatic levels coming up. Is that the correct interpretation of your question? No.
Yeah, it's like wet ponding more than dry ponding, and but unfortunately there is a water stream in the soil, which is during monsoon the water is trying to get out over the pond.
Look, what you might
At the base of the pond, while we constructed it in 2010 and 2012, there are a lot of streams were there, and we made the drains, perforated drainage, and collect the water one side of the pond and discharge it to the outside. At that time, what was made. Now in due course, these subsoil drains are choked. And now we are facing a problem, how to manage this water.
Professor Das, can you hear me? My internet seems to be dropping. Could you possibly tell if you can hear me?
Yeah, now you can hear it.
Look, I mean, that's a very pertinent question, and it happens. It happens when you transition from, and then you are not alone if you put it that way. Like I have seen that problem before. That happens. The first thing I will do, diagnose the problem. So if you have a meter the piece, or some piezometers or calcimeter piezometer, the standby, I would improve my monitoring just during the wet weather season, just to try to find out where the water is coming from. Is it coming from the sky? Is it the rainwater? Or is it actually the aquifer water which is recharging the phreatic level? Now once you have diagnosed, and it seems like you have done that bit and you know that the water is coming from underground, it's not the rainwater pre-monsoon. Once you have known it, the first thing I would perhaps do is to think about putting some dewatering wells or some sort of a dewatering sphere or some weed drains to lower that phreatic level, and then you can also think about clearing those drains. If it is, you could possibly, it's not a road solution, depends upon how big your challenges. You can think about, and I've seen this happening, building a cut-off wall. Like once you have known where your stream of water is coming, if you can think of putting a cement bentonite cut-off wall or something like that, that would intercept the water, and that can provide as a physical solution. But again, these are some sort of recommendation, not design advice. So you could possibly look at putting a cut-off wall. If you have identified that it is groundwater that is recharging. So in the short term, you can put weed drains, dewatering spheres. That's going to take the phreatic level below. But if it is a groundwater, they will come up. It's not like a fail-proof solution. So weed drain, dewatering spheres will take it to only for a momentary or a short-term medium. In the long term, a cut-off wall would be the way to
Okay, thank you. Just I want to show related to this.
I think that's the way we are going. In any new, like we have already decided, any new facility has to be lined. Because the main thing is, I don't know how in India there is a treating, because we have a deep level groundwater, but still we are using the liner to make sure that solution, like whenever, like any tailings facility, you will have a base flow. Like we can see that the seepage coming out in the water. That's what we call it base flow. So that base flow, something is also coming out. Something can also percolate, like go to the infiltrate and go into the groundwater, and also pollute, like contaminate the groundwater. So we have to protect that. So that's why most of our tailings dam, we have monitoring wells, and if we detect anything, we extract that water and put it back. So that's how we protect it.
Sir, in case of raising height, this question in the case of raising height of dam, original dam is not unlined and now we are raising the height, so we should apply lining or not?
Again, when you are raising it, where you will put the liner, like on top of that?
Yes, sir.
How much it will help, like because you already have the water. That water will definitely go. And when you are like when you load it, then that allows the consolidation. For the consolidation process, you have to load it. When you load it, that the water in the bottom, when they consolidate, then it will come out. So in the raising time, we don't use any liner for the raising. Yeah.
Okay, so our previous question is because you were talking about what happens, suppose say liquefaction, this what happens. The bottom portion you have got a like a slurry. Now you are making a dry disposal. This is schematic drawing immediately I had, so I put it. It's not exactly telling that, but the slope what happens. You see, sometimes it may so happen that this liquid mass which was below this dry stacking, it may also come out of it. Because that will be like a fluid. That is static liquefaction under pressure due to rise in pore water pressure. So this comes out. If suppose it would happen, this should not happen, maximum the slope will fail and after a certain time it will be remaining there. But if it is not so and you have got a already wet tailing and above which you are putting, you see the spread. This is a schematic diagram of showing such issues when we have got wet tailing above that dry stacking and that wet stacking, or that also what you are saying in the groundwater, and mostly it could be in the situation of liquefaction. So that will, I mean that is the most possible part will happen if it reaches to that stage where the load as it is increasing and any chances there may be a slide like this. Hope this is the diagram I could get most immediately to say answer your question. This happens actually. This has happened for not for the tailing dam in other slopes. If the bottom foundation is weak with lots of pore water pressure.
Sir, the underground water is below the liner, and at that time we put the under drainage system below the liner.
Okay, so you see Dr. Ponda has already said it. So this liner what we are providing, that is this geosynthetic or geomembrane, geoliner, what you say, they have a different purpose. You are not putting as an impermeable layer, maybe as a separator. Because the road also provided, suppose we have got a thin layer of weak subgrade. Then put a geometric style impermeable layer, then over that put the concrete also. So that what they are providing, Dr. Ponda, might be like a separation layer.
Yeah.
Not like an impermeable layer. It is a separate.
Below the liner, we have also clay with bentonite mixed powder.
That's why I say.
300 mm thickness.
Exactly.
Above that, we have laid this.
So that is a composite. Your liner you are talking about. So that is a composite clay liner.
Double impermeable layer.
That you have put some bentonite impermeable layer. Then the geosynthetic or line. Again that composite. This one. This is what we are talking about.
Yes.
So that becomes a liner. But if I simply provide a geosynthetic or geomembrane, whatever you call it, sometimes it acts like a separator also, to separating two zones.
But sir, this is HDPE liner. It is highly impermeable.
Impermeable, I found, but HDPE impermeable, what you want to make? You want to what you want to be impermeable? The water does not allow to get below.
We don't want to get the water to go down.
But below there is already water. Because that is a below, already there is water.
Below the liner.
Below the line already there is
Already
water.
water is there. So that water will come out.
That water will come out.
Because you are loading it. We are putting load on
But
top.
sir, it will come out laterally, it will not come out.
How it will come out vertically?
Impervious
If
layer.
that pressure exceeds the resistance of that line,
It can come out.
it can come out.
Yeah.
Because we have the stacking of 20 meter.
We have seen that.
And it will puncture this.
Yes, yes.
It will puncture the liner?
Yes.
It will puncture the liner,
It
sir?
can puncture the line.
Depending on how much load you are putting on top of it.
You can use some dewatering spares. Dewatering spares are doing drains to lower it momentarily while the groundwater is lower. Use like a slip pile or something to cut off that flow from the, once you have found out the flow paths of the aquifer wherever it is going, and then you can put the bentonite, sand bentonite. So it will still recharge, but the recharge rate will be much lower. Maybe an approach.
Look at this.
Sir,
Here you have provided impermeable layer. Here you have provided impermeable layer, suppose.
Yes.
Now what will happen to the bottom one? So they will try to sift through this. And what is said, suppose that it will become very much unstable, because then what will happen? This will try to slide.
We are not getting any water comes out from outside the dike.
No, here. You see, outside deck you are checking it here.
Yes.
But have you checked the pillow foundation when there is a layer like this? Because what you have done, if I show it now, let me show here. I have provided a membrane here. Okay?
Yes, sir. Yes.
So this, what I am saying, it will pass through drain, then I have to provide a filter here. So through filter, the water is going passing through that. But now think about the water below. So when this dam will be rising, because that is the permeability, what we are thinking it as impermeable now, because the problem is less, as I am increasing the height, the stress increases, the permeability of this one will start decreasing. That means more water will flow through this.
The seepage water.
Seepage
will go.
Seepage will pass through this.
Okay, sir. You are telling that still the water is inside our pond.
Yes. Because this telling below that line water is there. Only thing what is there, you are not able to see, but this may be 500 meter or maybe 2 kilometer.
Okay, sir.
So that is going through that and coming somewhere else.
It will cover large distance.
Yes.
No, we are in a confusion and where this water goes.
No, like,
No, if suppose say this is already, this was a level and this, there is any sloping ground here, there you can check. If we are coming through this somewhere. Because if it is a flat ground, how much distance you will check?
But sir, that water can go lateral, horizontally also. Why it will come upward only? It can go horizontally.
Then horizontally,
if there is no path.
Downstream side. We are not getting any water.
No, you are not getting. Below the liner actually. Below the liner. If we are putting the load, so sir is saying the water will come upward only. So it can go horizontally also. No, that's what I mean. It will find its path.
If water finds some way.
Path. It will find its path. Sir.
Yeah, if you find the path, it will go. If you don't find the path,
Then it will come upward.
because we are seeing more pressure is rising.
More pressure is rising, but
Yes.
water will find its
That
own
more
way.
pressure will put again the upward load also.
But generally, sir, water finds its
And we have seen, like we have done that, like we try to dewater the clay. We put big embankment on top of it. We see water coming and saturating our embankment
So
also.
we have to install piezometers.
Yes, to measure it piezometer. And Dr. Mishra said that also you can use some dewatering technology.
But
from
again, my thinking is, what was the function of that liner? Like, why you put a liner on top of the pond? Like, what was the function? Like,
Base of the pond, sir, not top of the pond.
base of the pond.
No. You are saying you have already pond there, and then you are changing it to the trash tank. Correct?
that becomes the top of the tailing ना, old tailing का top हो गया वो.
Opening का top में sir कोई liner नहीं है ना.
Oh, okay. So liner is in the base.
The base only.
Oh, okay.
Bottom.
Only bottom.
Oh, okay.
And below the liner, we had this perforated drainage system.
Okay.
To collect
Okay,
the
no, that's
stream water.
good.
So then
That's good.
In between, if it is not there, then no.
But your water table is shallow.
Water table is?
Shallow. How deep? How deep is the water table?
Water table.
So we don't have piezometers inside pond.
Because this is what I have visited when I am visiting, that is the problem. I am at least saying whatever small maybe, I am saying at least put some piezometers. That itself will tell you that is a very good indicator. And nowadays it is very easy, even 50,000 as a maximum in boring and extra.
So because we are, both the ponds are operational. None of ponds we have declared as.
No, don't put in the pond now. On the side of the embankment you can put it and check it.
Side of the pond we are doing now.
So that's what I said. You're not in the pond now, you cannot do it because of operation. But on the side you can do it. Okay, so I think the tea is ready, but this discussion, I mean, anybody else want to add anything? Yes, please.
सर हम लोग सर टोटल 6 हैशटैग्स है जो आपस में इंटरकनेक्टेड है, तो उसमें से 3 हमारे रिक्लेम पे क्लोज हो गए 2023 में, पर जो क्लोज टैग्स है उसमें अभी भी सीपेज वाटर ऑब्जर्व किया जा रहा है बॉटम में, तो उसके रीजंस क्या होंगे सर?
Those seepage water is coming from the surface flow or?
No, operational dikes are connected with closed dikes.
Oh, operational dike. Okay.
So what are the reasons, sir?
No, like in your operational dike, you are still putting.
Yes, sir.
So the seepage is coming through that.
Maybe the reasons are.
Yeah, so that's why we are discussing how we design this upstream, how to maintain the beach width. So we do not allow the water to come close to the embankment. Because if water is close to the embankment, you cannot stop the flow. Flow will happen. And that's the issue. That's why the embankment, we are assuming embankment is drained. There is no water in the embankment, it is dry. That's how it's an embankment. Because all these big hydro dams are staying there because they are good. And also we put filter in it. If there will be any flow, then it will be intersected and then drained out. But if you do not follow the design procedure and you just have an embankment and the embankment of any material, it doesn't matter, embankment of any material, we assume that it will stay drained, but we know these soils, we cannot control the soil unless it's fully designed by us, the soils. Most of the material you are again getting from the mines there itself. So you are again using them only. And if you put water very close to it, water will go into it. Once water enters the embankment, then you don't have any control unless you put the piezometer and monitor it. And if you see it is rising, then you have to do something. Because you cannot just wait that it will rise and then become another
Sir, what is the cutoff for?
No. You see this seepage is going.
Yesterday I was talking about the increase that distance बड़ा कर दीजिए so that the exit gradient will be less, but it will take more path to travel, so its pressure कम हो जाएगा.
It will be provided, sir, at the downstream side or upstream side. At the downstream side of site.
No. You are using cutoff wall mainly to prevent that flow goes. But again, lot of these hydro dams, you see in the core, you have a impermeable core or also it goes to the cutoff wall, and that cutoff wall will be connected at depth to the impermeable line.
Sir, we have to consider the initial construction.
Initial construction.
Like this. Dr. Mr. told whether you go for relievals and the cutoff wall.
Okay, so that you can, Dr. Mr. That is only possible maybe outside, seat pile wall maybe. Dr. Mr. are you there? Hello?
This is how we will go.
Okay, Dr. Misra, so now the point is that, suppose say now this is operation, they want to go for a cut-off wall.
So I think I agree or deny if I was involved, but there was a cut-off, there was one scenario, it was not typical of what you're mentioning. We had one tailings storage facility which was, wet tailings, but at a really low moisture content, 15 or 20%, right next to it, about 50 meters down south, we have a what they call like a decant pond or a big water reservoir, and water was actually coming through the foundation. We found out that it is coming and increasing the phreatic level in the dam. So we actually designed a 1 kilometer long cut-off wall. You can read it online. It's a 1 kilometer long cut-off wall. We spent about $20 million, and it cuts it up. It does what it was designed for.
So the point is that. So the point is that on the downstream side, you did that cut-off wall?
Upstream side.
Upstream side.
You have the dam here, and then yes, it's two of the dams. So it is between the water reservoir and the dam. So between them, it's on the downstream side. Yeah.
Okay.
Yes, you can see that, but again, what you have to look into, what is the purpose? In one particular site project also we designed cut-off wall in the downstream side because there was a creek like a river. So like you see it's going much deeper into the foundation. That's the case. So anything will go there, and then not only cut-off wall, we also design this extraction well. Because in the cut-off wall we stop that, extraction well will take up.
We have to evacuate the water.
Exactly.
So this is beach weight, this is what important. Yesterday you were talking about this beach. So this is important.
Sir, in this only I have one question. सर जैसे ये स्टार्टर डैम में हम लोग जो फील करेंगे मटेरियल, वो तो हमारा जो बाय प्रोडक्ट होगा दैट इज ओनली वी आर
स्टार्टर डैम में तो अभी बाय प्रोडक्ट आया नहीं, तब तो स्टार्टर डैम बन गया।
तो सर स्टार्टर
डैम में जनरली नेचुरल सॉइल से आ जाता है, और स्टार्टर डैम जनरली विद नेचुरल सॉइल, बिकॉज़ दैट टाइम यू हैव नॉट स्टार्टेड विद द प्रोडक्ट।
ओके, सो व्हाट इज द मटेरियल इन स्टार्टर डैम सर?
Started with the ordinary soil. What we are doing for the other earth retaining structure, water retaining structure.
Sorry, sir.
It's a hydro dam. Like
yeah, but it must contain some material, no sir?
Soil.
Soil, clay, sand.
You see, same like
Natural soil.
Natural soil or rock fill, it's well compacted and it is designed like a dam.
The water retaining dam. Just like water retaining dam.
Yeah.
So sir, because in one of the slide you had mentioned for the permeability also K1, K2 and K3. Now sand is having high permeability and then slime is silty material which is having low permeability, and the starter dam is having the highest permeability, right? So water will flow
Again the starter dam is the starting thing.
Yeah.
But if you go back to that drawing,
The raisings are made up of
Tailings.
Only tailings.
yeah. So anything close to the dam, like we have to make sure that there is an embankment and then the pond. So that's why the water we have that beach, because close to the embankment we are always trying to put the coastal material like drained. Any water comes there, it can be easily drained out.
Okay.
So this is the diagram we are talking about.
This slide I am talking about.
Yeah,
Because we are increasing the height by putting the our material, our red mud or any other material.
Yeah.
So we are raising the height. So there we need higher permeability so that water can flow down.
The high permeability will be a good material.
Yeah.
Definitely.
Correct.
Your sand or above sand.
Yeah.
That's why I said
well compacted.
Coarse grain material.
Coarse grain material, well compacted and drained. That's why we assume it as a drained material.
So that's why I said company, they got slag, with that they build it. So now it is very porous, water is going out, very steep nothing is there, no problems occur. It's not really designed properly for such a height, but because everything is, water is going out.
Sir, if the slurry is discharged in the middle of pond, then this case will not happen.
That's pipe. Because our system in Indian context, what we are doing, Dr. Panda, so our disposal system is very close to environment.
Very close to environment, correct.
So
and
that
there is no cyclonic.
No cyclonic.
No cyclonic.
Because cyclonic, if you see, might have seen that technique is yet to be joined and started in India.
This beach you see, beach has to be slow. You have to make it like a slope. So that when you
certain degree to any certain degree to that slope.
Yeah, like
20 feet is the minimum distance we should maintain.
No, 2000 feet.
So 2000 feet.
Yeah, and with the slope. With the slope, then what will happen even if you put the whole tailings, like you are not separating it, if you put the whole tailings, still the final will go further and cursor will get deposited. But you have to allow that beach to develop.
Is there any certain degree to that slope?
Again, we put like a 5 degree mountain this slope. Yeah.
And now the industry is using flocculants to settle that tailings. So that you can, suppose your beach length is less, so now the new chemicals are coming that which can flocculant, they're using the flocculant in the slurry so that it will settle in the lower distance.
They're using that.
Also, spigotting can be planned accordingly. Like where you place the spigots can be planned in such a way that the beach forms at a safe distance from the embankment.
Yes, sir. It should be near 1,000 feet of the beach.
You should move around the spigot such that the beach is formed in a safe distance.
So this is cyclonic, this picture. You have seen all these waves on it, but this is more than 1 hour almost. So but everybody might be looking for tea. So Dr. Misra, so actually, if you want to add the last moment, one line you want to say to our delegates. Dr. Misra? Yes, please.
Construction is low. Exaggerates the especially technical side. What I really wanted to highlight is the facilities that you are designing, always design like how with that in mind if you design, even your closer cost to whatever don't be mined. GISTM and all those standards which were being said, I don't do customer standards. It's very difficult to standard comes to picture when you have materials which are uniform, tailings are not uniform materials. So I would rather go with a good practice rather than standards. And the way we should look at them, not like we have to abide by this because it's a technical thing or a standard thing. Then focusing on that, this is how we integrated into our daily operations that we follow those practice guidelines.
Okay, thank you, Dr. Misra.
Definitely that is more stable.
So, thank you, Dr. Misra. So now, actually, truly, we were thinking of like making a good panel discussion on GISTM, but as I looking at the delegates' inquiries, I wanted to take their views, which is really they are facing in their operation and other things. So I thought that will be more fruitful of this workshop. Because this, as you know, this topic now only we are able to understand or they are able to appreciate. When Dr. Ponda came, he is coming with a different idea, different thought. What we are practicing in India, we are not doing in any way a holistic design, operation and maintenance of this tailing dikes or ponds or whatever you say. So this was just like hiring the people from different industries to say that how to manage these tailing dams, keeping in mind the most important point is the environment. And GISTM, that GISTM document is the first point, is the principle on which is developed. So that was the idea of this one. So thank you, Dr. Misra, for joining us online. And already it is too late, maybe 10:30 night. So thanks for attending, and your whatever amendment and other things it you next time when you join us physically we'll give it to you. Okay. Thank you. Thank you very much. Thank you, Dr. Ponda and other panelists. So what I can say now, our youngest panelist, Dr. Akhila. So now for the appreciation, I want to give him a memento. We give her a memento.
सर मेरे एमटेक सुपरवाइजर हैं तो अरे सत्यम तुम हटो
Thank you. Okay, so let's for tea already very cold. Thank you. Actually, really, I'm sorry because you missed class, but that was my idea that whatever the problem you are facing, Dr. Ponda has got a vast experience on the field. Something we should know from him so that in future, it may not apply at once, but we get to that somebody is there or some literature available. Somewhere something information available that you can already have. Okay, please.